Welcome back. We are concluding rational functions today with part 5, connecting graphs and rational equations. I'm Jason Athide, your host, and apparently I don't know how to type in a colon. Ooh, and this one's squared. Oh, rough. I don't even know if I can. Yeah. Yeah, I'm really sorry, everyone. I can't even. I'm sorry. They're going to have to be dots. I mean, I have the Word document. I suppose I could fix it, but rough. Anyways, this last section, except for that long intro where I criticize my typing abilities, is going to be pretty short. We are going to connect graphs and rational equations. We're going to see that we can, to an extent, solve some rational equations by using the graphs. It's pretty great. Over here we have a couple of graphs. One of those graphs is y equals 8 over x squared minus 16 plus 1. It's the graph of this. You know what would work better? A highlighter. You know what would work better? A bigger highlighter. Good enough. So it's the graph of that. That's what we're seeing over, which one is that? In red. And then in green. Oh, I'm still in partial eraser mode? How difficult. And in green, y equals 1 over x minus 4. Those are those two graphs. We can see some things in this graph. For example, they have an intersection point right over here where x is equal to negative 3. They also seem to kind of have the same behavior up here as we approach a value of x equals 4. So they're behaving the same way at those points. Everywhere else, they're different things. They're independent. They don't care what the other's doing. They're doing their own thing. But at x equals 3, they're exactly the same. And at x equals 4, it looks like they're approaching the same thing. That is enough information to actually solve the equation right up here. So 8 over x squared minus 16 plus 1 equals 1 over x minus 4. We can get that solution from this graph. This point of intersection, the x value of it, is the solution to that equation. And if we were to actually go through the process of solving it algebraically, we would even get an extraneous solution where x is 4. And we have this asymptote, and they seem to be doing kind of the same thing. So we can use this graph to find that information. You could also do it this way. You could take all of this business and shove it to the other side and graph y equals that. If you did, you'd get this graph here. And the 0 would be your solution. So that's that. We'll see two examples. One where we're after a certain y value, one where we're just kind of checking out what could happen. But we're also going to make sure we can still solve these things algebraically. They're kind of necessary. Just remember that the key thing we're using here is that the roots of an equation will be the same as the zeros of its function or the x-intercepts of its graph. So that's that business. Example! Woo! This is the graph of y equals x over x squared minus 4. It's beautiful, and I love purple. You seeing this purple? That's the kind of color I would paint my bathroom. Absolutely. The joke is that I painted my bathroom that color. And I love it. We're going to solve that equation. Well, we already have y equals this left-hand side. What we don't have is y equals this right-hand side. So where is y equals 2? Well, we don't have to draw it, but just to make a point. In, I don't know, blue. Y equals 2 goes right across there. It's that line. It goes on forever, that way, forever. That's y equals 2. And our points of intersection are right there and right there. Now, if we really look closely at that, like maybe it's not exactly at that point, like this. Does it cut through perfectly? I don't know, it's pretty close, it's pretty tight. But it looks like our points of intersection happen when x is over here, which is like -1 3/4, and over here, where x is 2 1/4. So it looks like those are solutions. Let's see what happens when we solve it algebraically. In this purple. No. Yes. So algebraic solution. This is going to require your abilities from maybe a little over a year ago for solving rational equations. Let's do this. Left-hand side, we have x over x squared minus 4. We're saying that's equal to 2. We have some non-permissibles out of this, so let's just make sure we note that x is not positive or -2. That would make a denominator 0. That would be bad. This one doesn't look that bad to solve. We just need to get rid of that fraction-y fraction. Multiply both sides by that denominator. Boom. We're gold. Oh, this is the best. Easy peasy. This is not factorable. Rough. All right. We're getting quadratic equation on this. Quadratic formula. I said equation. I'm so sorry. It's my first day on the job. I've never done math before. This is 1 plus 64, so this is 65. Next is -b plus or minus root of b squared minus 4ac all over 2a. So 1 plus or minus root 65 all over 2a, so 4. Neat! Are those values anywhere close to whatever we predicted they would be? And like the square root of 65 is pretty close to 8. 65, what's your square root? So like 8.06225774829855-ish, if I were guessing off the top of my head. Oops. So one of the solutions, just calculating what that value is on my calculator, is 2.26556 blah 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 blah, which is pretty close to our 2.25 that we stated earlier. The other one is -1.76556 blah 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 blah. So again, very close to what we stated. Wow, we have sick estimation powers. Good job, us. High five. The next example, what does it ask? Does it ask for the solution? Does it say find this intersection point? No, it asks for specifically the extraneous solution. Oh, okay. Okay. Well, it looks like if these things were intersecting, like this would be the actual solution. But they seem to be doing the same thing right around here. They're approaching an asymptote. So that is probably our extraneous solution. So we're guessing. Nah, we're stating this as fact. It's not a guess. We're brilliant. So the actual solution would be where x is -1. But the extraneous solution, that's what we're being tasked with finding, happens when x is 2. And we're going to get that. Now, I will warn you. This can get a little gross. And you do have to be very careful that you don't accidentally eliminate solutions. The fact that we know that x equals -1 is a solution, and that we know that we should arrive at x equals 2 as a solution, can help us a little bit along the way. But, oh boy, we're in for a treat. Algebraic solution. Alright, we're dealing with like x - 3 times x plus 1 over x - 2 times x plus 7. And we're seeing where that's equal to x plus 1 over 2 minus x, 2 plus x. Yeah, I know it looks different. I factored. And we do have to note that whatever solutions we get, x will not be positive over -2, and it will not be -7. Okay. Alright, I'm going to address the fact that this thing is flipped real quick. Like, right, you see that? What is that? What is it doing? So I'm going to factor out -1. Left side I'm keeping exactly same. Factor out -1 so that I can say 2 minus x is the flippy-do of x minus 2. That's that. I am going to cross multiply. It's not the only way to do this, but that's the way I'm doing it. Looks like a little bit of a terror. Whoa. And avoid the temptation at this point to say, well, x plus 1 and x minus 2 appear on both sides. I'm just going to cancel those out and solve something a little simpler. If you do that, you're eliminating solutions. And you really don't want to divide by your variable, if possible. You can factor it out if everything's on the same side, but don't divide by it. The reason you might know to not divide by that is because those are related to our solutions. We should be getting x equals -1 as a solution, which would happen from this x plus 1. And we should eventually get x equals 2 as a solution, which would happen from here with this x minus 2. So those are just ways to kind of signal or to indicate that you'll not want to divide those. Any case, I'm bringing everything to the left side. Oops. Whew. I'm going to factor out this common factor. Boy. Okay. And from here, things are just a bit more straightforward. So solutions, if a product equals 0, is wherever any of those factors is equal to 0. So x could equal -1, it could equal 2, or wherever x squared plus 1 equals 0, but we know that never happens. So this would be our solutions. Double check with our non-permissible values. We say hard nah on that one. And just x equals -1 is our solution. Oh my goodness. That was a difficult rational equation to solve. Bide, what are you doing? I don't even know. On the bright side, you wouldn't be expected to solve that algebraically. Not this one. You would still be expected to determine the actual solution and the extraneous solution from it, though. So more than anything else, make sure you know how to get those two things. This one, less important. There is practice work. So try it out. The textbook will probably not have something like this nonsense to do. Thanks, textbook. You're nice. Mr. Thad, you're mean. And that is the end of this topic. Whoa, my pen. I need this to live. So there is some review, textbook reviews listed there. Here are the questions that were on the January 2019 provincial. If you want to give those a look-see, they are worth trying. You can see that complexity of the equations-wise, not the worst things in the world. But let me know if you have questions. Try everything and see what you can do. And I will be here if you run into any difficulty whatsoever. Yeah. After this, one topic left. Woo! Let's go!